Before we practice a few examples, let's review what the rules for counting significant figures are. So here we have the 3 rules. Number 1 says that non-zero integers are always significant. So if we had a number like 12, we have 2 integers, so that means we have 2 significant figures. And if we had a number like 454, we also have 3 integers here. So we have 3 significant figures. The second rule deals with zeros, and we have 3 different situations with zeros. So the first one is leading zeros. So leading zeros are never significant. So if we had a number like 0.0012, these leading zeros are not significant. However, we do have 2 integers, so because of that we have 2 sig figs altogether. And then the next situation says if we have trapped or captive zeros, and they are always significant. So if we had a number like 203, here we have a captive or trapped zero, so it is always significant. So we got an integer, a trapped zero, so that gives us 3 significant figures. And then if we had a number like 0.000105, then we see that we have leading zeros, we have a trapped zero, and then we have 2 integers. So we know that the leading zeros are not significant. However, the integers and the trapped zero is, so this number has 3 significant figures. Alright, the next one says that trailing zeros are significant only if we have a decimal point. So for example, if we have a number like, let's just say 20,300, when we look at it, we see we have a trapped zero. We see that we have 2 integers, so we know those are all significant. But we also have these trailing zeros, and the rule says that if we have trailing zeros, they're only significant if it has a decimal point. So this number does not have a decimal point, so those trailing zeros are not significant. So in this case, we have 2 integers, 1 trapped zero, so we have 3 significant figures. And then in the case that we do have a decimal, so just say we had 20,300.00. Here we see again that we have these 2 integers, we have a trapped zero, and then we have 4 trailing zeros. And then we notice that this number does have a decimal point, so we know that in this case, these trailing zeros are significant. So this number has 1, 2, 3, and then 4 trailing zeros, so we have 7 significant figures altogether. Alright, the last rule says that exact numbers, which are counted quantities, have unlimited significant figures. So if we had a number like 6 marbles, this is a counted quantity, so this is said to have unlimited significant figures. On the other hand, if we had like let's just say we had a cup, and then we use a ruler to measure its height, and let's just say it was found to be 6.05 inches. This is not a counted quantity. Instead, it's a measured quantity, and in this case, we have to apply the other 2 rules up here. But rule number 3 is just saying that if we have a counted quantity where we actually are counting individual items, this does not have any uncertainty in it, so it is considered to have unlimited significant figures. Alright, so keeping these rules in mind, let's go ahead and practice a few problems. So here we're asked to identify the number of significant figures for each of the following. So number 1 says 47 feet. So rule number 1 said that integers are always significant. We have 2 integers, so we have 2 significant figures. Alright, the next one, 99.0 degrees Celsius. Here we once again see that we have two integers, and we also have a 0, and this would be a trailing 0, and the rule for trailing 0 says it's significant if the number has a decimal point, which this number does have. So that means the 0 is significant. So altogether we have 3 significant figures for this quantity. Alright, the next one says 0.00203 centimeters. So we can see we have two integers, we have a trapped 0, these are all always significant, and then we have 3 leading zeros, and the rule says that leading zeros are never significant, so we're not going to consider them. So this leaves us with 3 significant figures for this quantity. Alright, the next one says 0.0458700 gallons. We see that we have some leading zeros, which are never significant. We have 1, 2, 3, 4 integers, which are always significant. And then we have 2 trailing zeros here at the end. And trailing zeros are significant if we have a decimal point in the number. This number does have a decimal point, so these 2 zeros at the end count. So altogether we have 1, 2, 3, 4, 5, 6 significant figures. Next one says 68,100,000 atoms. We have our 1, 2, 3 integers, and then we have 5 trailing zeros, but this number does not have any decimal point, so these trailing zeros are not significant. So all we count are the integers in this case, so we have 3. So we have 3 significant figures. Alright, one more. We have a 10.0 millimeters. We have 1 integer, and we have 2 trailing zeros. We have a decimal point in the number, so that means these are significant. So we have an integer, 2 significant zeros, giving us 3 significant figures in total. Alright, so now let's practice a few slightly different types of problems. So here we're asked to identify the number of significant figures in each case. The first one says a sample of grape juice contains 0.00102 grams of vitamin C. So first of all, we have to identify whether this is a measured or counted quantity. So we know that this is a measured quantity. And now we're going to use our rules. So we have our leading zeros, which are never significant. We have 2 integers, and then we have a trapped 0. Those are always significant. So we have 3 significant figures in this case. The next one says, in a marathon, 60 runners started, but only 21 finished. So here we have 2 quantities, 60 and 21, and we're talking about runners. So we know that this is a counted quantity because we can't have half or a quarter of a runner. So this would have unlimited significant figures because this is not a measured quantity. This is a counted quantity. Alright, finally we have the length of a book was found to be 9.30 inches. So once again we have a quantity here, and this represents the length of a book. So we know that this had to have been a measured quantity, probably with a ruler or measuring tape. So that means we have to use our significant figure rules, which says that integers are always significant. Trailing zeros are significant if we have a decimal point in the number, which we do. So this quantity has 2 significant figures.